Today we're going to talk about a topic in geometry that's called pool ball geometry, but it is also the same as the concept of mini golf. And what we're looking at, both of those sports involve, or hobbies, activities, whatever you want to call them, involve a ball and a location to hit it into, either a pocket or a hole. And both of them have obstacles, either the edge of the pool table, or in mini golf there's various obstacles throughout the course. So looking at this picture, if our cue ball is at the blank ball location and we're going to hit towards the 4 and we want to hit the 4 into a pocket, is it actually going to go in, and what pocket would it go in if it's going to go in a pocket? What do you think?
Bottom corner.
Bottom right? Any other thoughts? Agree, disagree? Yeah, if we use some like pool skills and kind of skimmed the bottom, we might be able to get it into that top center, but we're thinking like hit it straight on. So hit it right in the middle of the ball, straight on, so that it's going to follow that same path as the arrow. Okay, so somebody thinks it's not going to go in any. It might end up tapping one of those other ones. How can we know? How can we know what's going to happen here?
We draw a straight line with 2 box points, and then we do, like, I don't know, a right angle or something.
All right, so let's say I hit through here. That's how it's going to hit the wall. What's going to happen after it hits the wall? It's going to bounce. How is it going to bounce?
It's going to have the same angle.
It's going to have the same angle. So that angle that it hits the wall, it's going to rebound at the same angle. So we could grab a protractor or something to try to figure out exactly what that angle would be. But it looks like maybe about there would be the approximate angle. So we're going to slightly miss our target. Now it might be that once it hits that wall, it's going to take several more bounces, and maybe it'll end up hitting somewhere if there's enough power behind it that it can keep going through all those bounces. But it's going to slightly maybe miss that pocket. Now I didn't use a protractor, so maybe it will, but it's going to be a close call on whether or not it would hit that bottom pocket. The angle in should be the angle out. So whatever angle it hits the wall, it's going to rebound at that same angle, which is actually what the law of reflection says. So right underneath that says law of reflection, and that is that the angle in is equal to the angle out. So we're going to look at proving that law of reflection. You will not be doing proofs in your homework, but just because you shouldn't necessarily believe everything I say right off the get-go, I promise I'm not going to try to lie to you, but it's a good thing to verify, right? So how do I know for sure that the angle in is going to equal the angle out? So to verify that, we're going to look in this picture and talk about the process of how we can know how to reflect to be able to hit in a single shot and make our goal, or get a hole in one if we're thinking about mini golf. So our process of how we would figure out how to hit this ball, at what angle should I hit this ball so I can get it in the hole in one single hit, what we're going to do is take the hole and reflect it over the line we want to bounce off of. So I always begin by kind of eyeballing my idea of what's going to happen here. So I'm thinking my goal is I want to hit it this way so that it's going to bounce into the hole that way. Okay, so just kind of a sketch to get me going. Then what I'm going to do is the wall that I bounced over, I want to reflect the hole across that line. So I'm going to take the hole and reflect at a right angle, matching the distance. A reflection should always have the same distance. So I'm going to reflect that hole over the line that I want to bounce off of. Then we're going to aim the ball towards that reflection. What happens inside of our playing field will actually happen, but once I hit an obstacle, it's going to bounce. And angle in should equal angle out, bouncing it directly towards the hole. So the process is reflect the hole, not the ball, a lot of students do this backwards, reflect the hole over the wall you want to bounce off of, and then connect the ball to that reflection point, connect the bounce to then the hole. So now the question is, on the side here, to prove that our angle in equals the angle out. So we want to prove that angle 1 is equal to angle 2. So why would that be? I'm also going to label into here angle 3. So where's a pair of angles in that picture that we can know for sure are going to be congruent? 1 and 3. Why? Vertical angles. Now if we're trying to prove that 1 and 2 are congruent, and I've got 3 blanks here, that must mean we can't go quite there yet. So the next logical step would be to say that what 2 angles are congruent? 2 and 3. Now the why on this is a little bit more of a process. There's not a single step answer that's going to get us there. We have to think back to something we did a long time ago, like chapter 4. So when we made that reflection, we did so with some right angles. And when we make a reflection, we do so with congruent lengths. I said whatever the length from one side of our line of reflection is, we should mirror across that same length on the other side. Well, this side has to equal itself. So now I have a couple of triangles there that we could say are congruent. Back when we learned about congruent triangles, there were 8 different ways that we learned we could say they were congruent. Which ones would apply here? 2 sides are congruent, and we always need 3 things to say 2 triangles are congruent. So we've got 2 sides that are congruent, and what else?
Angle.
We've got an angle. So we could either call this a side angle side, or since it's a right angle, what kinds of sides are those? Legs. So we could say it's a leg-leg congruence. So they are going to be congruent then by a CPCTC. Remember that acronym? What did it stand for?
Congruent parts of congruent triangles are.
Close. Corresponding parts of congruent triangles are congruent. So that we'll end up with some congruent triangles there, and those angles will be congruent. So that was a big time review from a long time ago. That was like the second quarter where we talked about that stuff. But angles 2 and 3 would have to be congruent. We said angles 1 and 3 would be congruent, which then means angles 1 and 2 are congruent. Why? Transitivity. Our favorite reason. All right, I'm going to strongly suggest that you do this assignment in pencil because often your first instinct is not going to be the right instinct. So on this next one, I'm going to show you maybe what my first instinct would be and why that might be a problem. Okay, so you might not want to draw out this first thing. I'm going to say, let's begin by taking the hole and reflecting it over the bottom line. Then I need to mark out equal distances, so it's going to land right about off the paper, kind of right on the edge of the paper. So if this was my start here, and this is the first thing I did, and I'm going to tell you this isn't going to work, and we'll see why here in a second. Then the next thing I do is connect the ball to the reflection and connect the bounce to the hole. And that's a problem because I ran into another obstacle. So the ball wouldn't be able to make it all the way to the hole. So this isn't going to work. What that means is a single bounce is not going to be sufficient. We're going to have to bounce this thing off of 2 walls. So again, I said it's often a good idea to kind of eyeball it and think what'll happen here. So if I aim this ball down to the bottom wall, angle in has to equal angle out, it's going to hit somewhere over there and then go in. This is probably the approximate path that the ball is going to take. When you do your reflections, you're going to want to reflect the hole from the last wall that it hit. So I'm going to reflect over that vertical wall first. So I'm going to take the hole and reflect it over the vertical wall. Measure out same distance across. over to the other side. And I'm going to call that number 1, because that was my first reflection. Yes? Then we're going to have to make a second reflection over the bottom this time. So what I'm going to do is extend out the bottom and make a reflection now across the bottom. So that I'm going to end up getting 2 bounces. And once again, the lengths need to be the same. So again, it's going to hit kind of right on the edge, bottom of the paper. You can kind of cheat it a little bit. It's a badly placed margin. And I'm going to label that as number 2, since that was my second reflection. Now when we connect, we're going to connect the ball backwards. So you start at your highest number. Sometimes it might take even more than 2 reflections, but you start at your highest number, the last point you created, and connect that to the ball. What happens inside the field will actually happen, but now it's going to hit that wall and bounce. Where should I connect that bounce to?
The first one.
To the first one. So I'm going to take that and connect it to my first point that I reflected. What happens inside the course will stay inside the course, but it's going to hit the wall and have to stop, and I can then hit that bounce to the hole, and we get our path. Okay? So you start by reflecting the hole over the last wall that you want the ball to hit. And then you may have to reflect over another wall. And you reflect that new point over the other wall. Don't go back to the original hole. Go to your new point and reflect that over the next wall. So that sometimes it might take more than one. On your homework tonight, there are 2 problems that are drawn out for you. One of them will take more than 1 bounce. Then the third problem asks you to create your own course and solve it then. It does not have to be super complicated. You can make it super complicated if you want, but it must take at least 2 bounces. So the third question is to create your own course. It must take at least 2 bounces. It can take a lot more if you want. Some people in the other class, there's like 7 or 8 bounces, but that's up to you if you want to do that much work with it.
What page, the last page?
It should be the last page in your packet now, because we're tearing off from the back forward. Okay? So you have the rest of the class time to work on that.